So the next thing we're going to look at with surds is multiplying and dividing them. And there are two rules of surds that we need to be aware of. The first rule of surds, and we've been using this rule when we've been doing our simplification, is that if we've got the root of a times b, then we can split it into root a multiplied by root b. So we can use the converse of this in order to help us simplify. So in this example, we've got root 5 times root 10. It's asking us to simplify it fully. So the first thing we're going to do is we're going to use the converse of rule 1, and we're going to say that it's the square root of 5 multiplied by 10, which is root 50. Now, it says simplify fully, so we do need to check that whether or not we can simplify root 50 by checking if there's a perfect square factor. And there is a perfect square factor. So root 50 equals root 25 times 2. So you can see now we're going and using the first rule of surds in its traditional way in order to split that into root 25 multiplied by root 2. And then we're going to square root our perfect square, and we're going to end up with 5 root 2. And that is root 5 times root 10, simplified fully, becomes 5 root 2. What if we've got a bracket? Well, it's exactly the same way that we would do it if we were expanding a traditional bracket. We're going to do root 2 times the first term, so we're going to get root 2 times 10, and we're going to do root 2 times the second term, so we're going to get take away 3, and then we're going to have root 2 times 8. So we're going to end up with root 20, take away 3 times root 16. Now we need to check and see if we can do any more simplifying. So root 20, we know, has the perfect square factor of 4. So we're going to rewrite root 20 as root 4 times 5. And we're going to take away 3, and we're going to multiply that by root 16, which is a perfect square, so it's times 4. So in our next line of working out, we're going to split this into root 4 and root 5, and we're going to take away, and we're going to do 3 times 4 now, and that gives us 12. And our final step is to square root that perfect square, so we're going to end up with 2 root 5, take away 12, and that's our final answer because we cannot simplify that any further. So the second rule of surds deals with dividing surds. So if we are square rooting a fraction, then it means that we're square rooting the numerator and we're square rooting the denominator. So sometimes it's easy to simplify it by simplifying the numerator and seeing if there's anything that we can cancel down. But in this particular example, it's going to be easier to use the converse of the second rule of surds. So the first step we're going to do for root 20 divided by root 5 is to write it as root 20 divided by 5 as a single fraction. We know that 20 divided by 5 is 4, so the next line of our working out means we've got root 4, and that's a perfect square, so our final answer is going to be 2. When we've got the square root of a fraction, we want to check and see whether or not we can simplify that fraction first. And we can see that 18 and 75 have a common factor of 3. So 3 goes into 18 6 times. So we're going to keep our square root sign, and we're going to do 6 over 25. Now we're going to use rule 2 to split that into two separate fractions. So we're going to have root 6 over root 25. We can't do anything more with the root 6. It stays the same. And we're going to divide that by root 25, which is a perfect square. And so our final answer is going to be root 6 over 5.